Etherchannel and UDLD design. The state of Arizona, where I live, is always under construction. We're one of those places where no matter where you go, driving to get anywhere, you're going to run into construction barriers because they're widening the roads because more people move here because who wouldn't want to live in the middle of a desert, right? Well, in the network world, you have spanning tree protocol, which saves your bacon because it goes around finding the loops in the network and blocking the redundancy so that you don't destroy yourself. But in a way, it's very wasteful because it'd be like building backup roads in Arizona that we don't use unless the main road has an accident or something, right? It's crazy. So instead, Etherchannel comes along to allow you to bundle links in the same switch in powers of 2. Now, you don't have to use powers of 2, but the ASICs are designed for it. So if you do like 3 links or 5 links or something like that bundled together, you're not going to get good load balancing. You're going to get 1 link that ends up overloaded and 2 that are underutilized and all that. So 2, 4, 8 links work well when they're bundled together. Spanning tree protocol sees them as a single logical connection. Now, the way it works is a load balancing algorithm, right? To where you've got all these different hosts that are communicating across that. And typically, the load balancing is based on the source and destination MAC address. So anytime you have a different host and communicating with a different destination or some variance thereof, you're going to end up with a different link. It actually hashes those 2 things together, and each one of these links is designed to respond to a certain hash, right? Anyway, we're digging in deep. My point is that you're never going to be like, let's say these are all 1 gigabit per second links, right? And you bundle 8 of them. You're never going to transfer a file and be like, whoa, 8 gigabits per second of throughput. Doesn't happen in Etherchannel. You're only going to get 1 gigabit per second. However, total, when you start looking at all the hosts that are crossing to the different destinations, you end up using the different links. So you might get 8 gigabit per second total throughput, but no one host or one communication stream will ever go above a single link speed that's in that bundle. Does that make sense? So spanning tree sees this as 1 link. Once you bundle them all together, Etherchannel makes sure that there's no loops in the environment. So what does Cisco recommend as a best practice? They say use the negotiation protocols. Now, if you know me, you know I'm like, if you can hard code, hard code. Like static routes to me feel good because I'm like, go that way. And I know it's not going to change because I said go that way. Auto negotiation on speed and duplex, I'm like, yeah, auto not use it. Like, I freak out on auto things. I like the level of control until you get to Etherchannel. Why am I saying that? Why is Cisco saying that's the best practice is to use negotiation? It's because this will be able to tell if one drops out of the bundle. Right? So when you're configuring Etherchannel, one of the ways that you can configure it is called on. You go under it and you say Etherchannel essentially on, which says I'm not negotiating, I'm always on. Well, that's all great as long as both sides are configured as on, but what if? What if some wacko guy comes in here and is like, oh, well, let's just, reconfigure this port. Well, as soon as you change one setting where it's no longer compatible with the bundle, it drops out. Right? But this guy's like, no, you're on, which now you could end up with a loop scenario. Remember, Etherchannel's bundling multiple links that normally spanning tree would block, and now we've got links dropping out of the bundle without spanning tree there to recognize that there could be a loop. Toast, right? So if you're using these negotiation protocols, this one, Cisco proprietary, right? This one, industry standard. I'll just put industry right there. Industry standard. The only reason they're still around is because Cisco's awesome. And Cisco came out with this idea first, and then the industry caught up years later and created this. So it doesn't matter. I mean, one is not better than the other. I would say use PAGP just because we all have Cisco tattoos. And why would you need to negotiate with a non-Cisco device, right? But LACP is the industry standard. Use that. So the modes: auto, desirable, right? Desirable is like, oh, I want to be a trunk or trunk. I want to be an ether channel. I want to be an ether channel. Auto's like, I'm kind of like passive. Like I could go that way. I could go the other. So, key facts when you're designing. If you ever have two autos, it's like it's like me and my wife when we were dating, right? I'm kind of like a pretty laid back guy, and she's pretty laid back girl, right? And so I went 3 months, quote unquote, dating her, where I didn't even know if she liked me, because nobody's like, all right, let's do this, right? Let's. So I had to convert myself into a desirable. I desire, and let's. I'm married, right? So, desirable and auto matchup. Auto will just stare at each other and nobody will make a move. And that's the same thing with LACP. I like LACP's terminology better. This works better with dating. This one is just a little more logical in the network world. Active and passive, right? Passive, again, you get two passive links staring at each other and they're not going to become an ether channel. You want to have active passive. Now, can you have active active? Yeah, but shink. Best practice. Link comes up faster. For those of you that are like, milliseconds matter to me. It comes up faster if you got this positive negative relationship going on, like an active. Otherwise, they're like, hey, and it's like you get two sumo wrestlers that run into each other and like poof, they fall over and they're like, oh, yeah, okay, okay. I don't know where the sumo thing came from, but that's what happens. So you want to try and match them up in this active to passive or auto to desirable. On a somewhat related but totally different topic, we have UDLD, which stands for Unidirectional Link Detection. This, if I were to do it all over again, I would probably put this one in the spanning tree topic bundle, even though it's not spanning tree. It's just kind of like it. So what UDLD is a method that detects if a link has gone unidirectional without the use of spanning tree protocol. See, some people are like, spanning tree is from the devil and I won't use it, right? And they try to disable it wherever they can because they've got other mechanisms in place to keep loops from happening, and they want that ninja speed convergence. So the beauty of spanning tree is it has this feature called loop guard, right? Which allows you to go in there and say, you know what, if one side stops talking, that's not good. That means, BPDUs should be sent. We should be like, making this thing work well, and we should be talking to other switches. And if they stop sending BPDUs, then something's gone wrong. You need to block that link, because if you're not down and the other guy stops talking, then maybe spanning tree is broken, which could cause a loop. If maybe there was a spanning tree software fault or a switch froze but didn't go down all the way. I mean, just weird situations, but I've seen them happen, and it causes the whole network to crumble because you get a loop that takes the whole thing down, right? So the problem is, if you don't run spanning tree, you don't have anything to prevent against unidirectional links, which you can see this picture right here. How does that happen? Fiber optic, my friend. Fiber optic cable has that separate transmit and receive, TX and RX, right, pair. Where Ethernet cable, I mean, you hardly ever see this because the cable is either down or it's up. But with fiber, you could actually disconnect, and it actually is very easy to do, disconnect one side of the cable to where now you've got transmissions happening, right? But receive is not. And that could cause a loop in the network and all kinds of chaos. So UDLD, is very typical to run on fiber connections. What it is, its own little proprietary, I said proprietary, but it's not like Cisco made this, right? It's got its own little thing, its own little hello messages where it's like hi, 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 hi. And if one side stops saying hi, by the way, it sends those once every 15 seconds, bing, by default. It says, okay, something's gone wrong, and it actually blocks the link from operating, right? So the beauty is the best practice is it's one command, UDLD, and you can either type in aggressive or enable in global config mode, and poof, problem solved, right? Every fiber link is going to automatically run this, or you can turn it on in per interface if you really want to, but I'm like, hey, and Cisco is like, hey, save yourself the trouble, just turn it on globally and you're done. However, always type in UDLD aggressive, not UDLD enable, which is very common because people are like, who wants to be aggressive? Well, what enable does is if it sees this happen, it's going to send you a syslog message. It's going to be like, hey, FYI, administrator who's receiving 15,000 syslog messages every other second. FYI, got a unidirectional link. 15 seconds. FYI, still got the problem. You're going to miss it. Aggressive is the one that actually says, okay, you know what? If I don't hear this hello, I'm going to aggressively try to renegotiate the link. And then I'm going to disable it if I can't hear back from the other side. So you want to go with that aggressive, which takes action rather than just FYI. You now know Cisco's recommended best practices for Etherchannel and UDLD. I hope this has been informative for you, and I'd like to thank you for viewing.